Hello everyone, welcome back to our study of pre-algebra. Today we are working with numerical expressions and order of operations. If you happen to be using pre-algebra for Christian schools by Bob Jones University Press, this is section 2.1 and I believe that I am on page 41. So first, where did the school kittens go on their very first field trip of the year? Well, they went to the museum. Of course. And then, when they came home, what is the favorite game that the cat liked to play with the mouse? Well, they went out and played catch for a while. So, they're pretty lame today. I know, it's a dull, dreary day out there today, so just think about those cats and mice out there playing catch. We want to talk about multiplication and division, and we have different ways that we can indicate these operations. What you learned when you were very young was sort of like this X, and you learned that that was read 6 times 5. 6 times 5, of course, is equal to 30. And what this really says is take 5 and count it 6 times. 5 plus 5 is 10. Plus 5 is 15, plus 5 is 20, plus another 5 is 25, and the last 5 makes it 30. But this thing right here in the middle that we've used for multiplication looks remarkably like an X to me. So now you really know why I use that for my X, and why I do not use an X for multiplication. Another way that you can say this is with what they call a raised dot. 6 times 5 is equal to 9, is equal to 30. I'd love to know where that 9 came from. You can also use parentheses. 6 times 5 is equal to 30. If you have numbers and variables, you have 6 times n is equal to 30. Or you can just simply say 6n is equal to 30. When the digit and the variable are bumped right up against each other, just means 6 times. I want you to rapidly, like as in right now, stop using the X to indicate multiplication. Matter of fact, stop using an X that looks like that in any way, shape, or form anyway. Use a cursive X to represent a variable. If you want to use multiplication, the best ways are to use the parentheses or to bump them right up against one another if one is a variable and one is an actual digit. The raised dot is okay, but these two, example 2 and example 4 here, are your best ways to indicate multiplication. And then we also have division. We have 6 divided by 2 is what? 6 divided by 2 is 3. We have 6 divided by 2 is 3, and we have a fraction of 6 over 2 is equal to 3. All of these mean the same thing. All of the 6's are the dividends. All of the 2's are the divisors, and all of the 3's are the quotients. This is a review of your math vocabulary, and you do have to know the parts, the words of the parts of a division problem. Just like 2 times 3 is equal to 6, those things that you multiply together, remember, those are called factors. And the answer here is not a quotient, it's not a sum, but it is a product. A quotient is the answer to a division problem. A product is the answer to a multiplication problem. The sum is the answer to a the sum is the answer to an addition problem, and the difference is the answer to a subtraction problem. Okay, now, We know how to write division, we know how to write multiplication. There's no reason to review addition and subtraction, but what happens when we have a bunch of stuff that's grouped together? What happens if we have something that looks like this? 7 plus 9 divided by 2 times 4. What in the world do we do first? Well, this division bar in the middle, they call it a fraction bar. This is sort of like using parentheses. It says do everything that's in the numerator first, and then do everything that's in the denominator. Numerator of a rational expression, this is the denominator. So what's 7 plus 9? 16. 2 times 4 is 8. 16 divided by 8 is 2. There's your answer. So what you want to do first is symbols of inclusion first. Then you want to do multiplication or addition. Then you want to do multiplication or division. Then you want to do addition or subtraction. On the next page, on page 41, let me say that we have 3 times 7 plus 32 divided by 4. How do you know what you do first? Well, this acronym here, PEMDAS, will help you remember. The first two are parentheses and exponents, anything that groups stuff together, like symbols of inclusion, like brackets, braces, absolute value bars, they're parentheses. You know, they work like a parentheses. And exponents. Those are what you do very first. Next, you have multiplication and division. And you do those in order: multiplication and division. And you work those in order from left to right. And then finally, what you have left here, third order of business, you do addition and subtraction in order from left to right. So do we have any symbols of inclusion here? Parentheses, absolute value bars, brackets? No. So we don't have any first level priority. What about second level priority? Do we have any multiplication and division? Well, we've got multiplication here and division here, so what do? When you have the same level priority operations here, what you do is you move from left to right in order and do those first. So here we have 3 times 7 is 21 plus 32 divided by 4. We got rid of the multiplication, we have division. 21, not 21 plus 32 is 53, but we have division, so we have to do 32 divided by 4, which is 8. And then you see that you have evaluated this expression. All you're doing when you evaluate an expression is finding a value, what numerical value you have by using the arithmetic operations. So let's see if I can pick one more. This one right here looks like a very good example for me to close out this lecture on. And this is problem number 26 on section 2.1, and this is page 43. So we have 24 minus, open bracket, the quantity 3 plus 2 times the quantity 11 minus 8, close bracket. Oh, and that's it. Let me make sure. Page 43, 26. 24 minus quantity 3 plus 2 times quantity 11 minus 8, close bracket. We have several things going on here, don't we? subtraction, addition, multiplication. We have brackets and we have parentheses. So we have to use our order of operations that says, let's do anything that groups stuff together first. They call it, that fancy phrase is symbols of inclusion. It's where you're grouping things together. You can have brackets, you can have parentheses, and look at this, we have 2 pairs of parentheses and a pair of brackets. So what in the world do I decide to do when I said work in order from left to right? Well, you can't, because they only work in pairs. So what you do when you have grouping symbols is you work from the inside out. So we have 2 pairs of parentheses here. We're going to work from the inside out. We're always going to begin writing the problem from the left-hand side of the equation, left-hand side of the paper. 24 minus the quantity. What is 3 plus 2? It's 5. Times 11 minus 8, that's 3. Close bracket. We have multiplication and subtraction and brackets going on here. We do what's inside the brackets first. 24 minus 15 gives us an evaluated number of 9. So that's all you do. String, you've got a great big long string of numbers and parentheses and exponents and subtraction and division. Don't worry about it. Look for, the very first thing that you do is parentheses, exponents, absolute value bars, brackets, braces. You use symbols of inclusion where it says do this thing first. And then work with multiplication and division. When you've completed all of those, work with addition and subtraction. And do those in order from left to right. And you follow those consistent rules, you'll have no difficulty finding your solutions all the time. Enjoy your homework, and I will see you next time.